Now, since I want to show you like both ways, we're actually going to go and we're going to rename this thing to main1, right? In fact, I believe Metals can actually do this for me. Let's see if I can just do main1 over here like this. Yeah, it renamed the file for me. Okay, so I will also put all of this into a different scope. I'm going to call it scope 1. Okay, so now like this whole thing until the main, right? The main can still be out there. Okay, so I'm just going to indent it like one further to the right, and over here I'm simply going to import scope 1 star like this. Okay, so now that we have this thing like this, we're going to duplicate it. Okay, so this is going to be main2, not 12, main2 like this, and this is going to be scope 2, and at the bottom we're also going to have okay, so over here we're going to have 2 like this. Okay, and we're also going to start running the second one, right? So run main dev inside your main 2. Okay, so now we're running the second one. Let's actually have it a bit bigger and collapse it like this. There we go. So check it out. Let's go to the top of the file. Okay, in the business logic over here, we're going to say that we actually require Google. It actually needs to be Google. Because we're going to require it on the method level, we actually don't need to require it on the construction level, right? So this thing can become any, right? And this thing does not need to call from service. It's simply going to call succeed, right? Because make is not going to need Google like this, right? It is already injected over here, Google.Google, which is also why you can use Google over here instead of G. And by the way, this type would be inferred, right? So this is one of the things that I'm a little bit on the fence when it comes to ZIO, because ZIO sort of like this effect tracking route, it sort of encourages you to leave the types out, because otherwise they're gonna get like very, very long, right? But you know that if you leave this type out, it is already in the declaration over here, and it will be super, it would be inferred exactly like this. But I'm gonna leave it here for readability reasons. Okay, and now for this thing to work, we need to say over here that we don't require just the business logic, but we also need Google. Google. Okay, so essentially we're embedding the dependency graph, not just the dependencies, but the entire dependency graph already in the methods. And this will allow us at the very bottom, when we're actually assembling the dependency graph, to not be so explicit about how it should be constructed. We will simply be able to throw everything in there that it needs, right? We're just going to do like Google ++ business logic ++ console ++ controller, and how the dependencies are used is already embedded over here, right? It already knows how to do this. And therefore, we're not going to require to do something like this. We're not going to require to reassemble the dependency graph again just so that we can insert something in there. We'll simply be able to override stuff to an already assembled production dependency graph, which is insane. Let's go and continue with the pattern. Okay. Now, for Google, nothing is actually going to change because it actually never needed anything, right? So from the very beginning, it was calling, succeed over here. So nothing is going to change for Google. However, it will change for the controller. In fact, controller is going to start looking very, very crazy. So I'm going to mark over here any, right? So we're in the run. Okay, so we're over there, right? And this is the spot where we're going to need everything, right? So I'm going to say, okay, well, we need the business logic dot business logic, and we need everything that the business logic needs, which is Google, right? We're tracking effects, right? And we also need the stuff that we need, which is the console, right? Like all of this stuff, right? This allows us to go over here and just do succeed, right? Succeed was make. Make does not require anything anymore, okay? And now over here, where we do con, we can actually do console, right? And over here, where we do BL, where we're going to use the business logic. And now over here, when we run, we actually need controller and all of its dependencies, right? All of its dependencies is, like all of that stuff, right? And this thing. Okay, so succeed like this. All right, so everything over here compiles, like stuff at the bottom doesn't compile where we assemble a dependency graph, right? But look at this, we're tracking everything that we require. And by the way, at least in Scala 2, this has an advantage that you can introduce type aliases for all of this stuff, right? Like in Tegless Final, this was a common concern that, you couldn't abstract away these context bounds, right? However, in Scala 3, you can actually abstract them away as well. We have these context functions, right? It's these weird ones with a question mark. Also, it's very awesome in Scala 3 that that the intersection types are finally the proper intersection types, which means that they're commutative, right? So you don't need to have exactly the same order as you would need to do in Scala 2, right? So you can switch them, and everything's going to work out as long as you have all of them in place. All right, so now let's go and fix the dependency graph. Right? So now we don't need to do this nonsense. We can just replace like all of these guys simply with plus plus, right? And so we can, I'm going to indent it like this, right? I'm going to indent this one like this. Okay, so this is going to be alive like this. Now we don't need this. And technically over here, and this is a cool thing, we can actually just leave it out. And this is the place where I'm actually going to throw out the types. And I'm going to show you this relatively ugly type inference. Right, so this is one of those things where like the real ZIO does it slightly better, because if you look over here at the environment, the insertion point, it says like has service and has service, and it would say this even though like it would be any, right? So right now this actually could be any, and we wouldn't actually see it. Let me fix the thing, you know, at the bottom, and then we're going to switch to the real ZIO, and I'm going to show you how it's going to look like. So we don't need to change anything in the fancy console. Okay, so now over here. Okay, so like these guys don't well, they actually kind of do still work, right? No, they don't. Okay, because we have like this weird live thing. Okay, so let's do provide layer first, right? So this one should work exactly the same as it worked in the beginning. There's still an error somewhere at the top. All right, this should work. Let's look at this thing again. Okay, so it says it found a program that wants business logic service and the console service, and it shouldn't need the business logic service, which means that we forgot to use any at some place. Let's see. Probably when we're assembling the, yeah, over here, like this whole thing, right? It's any, right? This was the whole point, right? So that like these live things, like you don't need anything to assemble them. Look, there's nothing in there. Okay, this should be any. Yeah, there we go. Cool. So let's go down. So now this is a program that wants some sort of has, right? Like this is the thing. Like it actually wants any. Right, so I believe that if we go and actually do ZIO any IO exception and unit, it's going to be fine. Maybe. Let's try with, yeah, see, like this is fine. Like if we do like has if any, then this thing is going to compile, but now this thing is not going to compile because we don't, like I didn't like mimic this trick that they use in ZIO that kind of like can map between like has any and any. Okay, so we're just going to leave out the type, and it's going to be fine, right? So in fact, maybe I can switch to the real ZIO, right? So over here, for example, the infer type is like has question mark. But if we were to switch to the real ZIO, right, and we go down, then the type would be any, right? So this is like this trick. And also like the infer type over here in the environment over here, right? So it has like any, right? And then it always like shows you like the first service, like this is a Scala 3 thing, right? It shows you like the first Google, and after this, like for some reason it forgets the type aliases, so it just says like has service all the time, right? So but actually it's like, you know, it's the console and the business logic and the controller. But in the partial, like in the constructor, like in the reader part, which is like somewhere over here, if I move my mouse, this pop-up goes away. It actually wants the has service. In fact, we actually don't need the partial thing anymore, as you will see in just a second. And by the way, it's totally wrong. I actually want to do this plus console at live, right? Because I want to say that you don't need this one, right? You don't need this one, right? Doesn't matter what you specify over there. This is what I just noticed, right? So this is how I meant it, right? Like you need like these three things, but the console you don't even need. So what this allows you to do is play around with the map that is wrapped inside of the has, you know, that is wrapped inside of the Z layers and so on and so on. Okay. So for example, you could go and you could say, like you could have this line over here, right? And you can go and you can say, inject the fake console live before, right? So now like this is the fake that would like make the printouts green, but then you inject like the real one over here and it's getting overridden, which means that if you swap the places, right? And by the way, we weren't even running it like this, right? So this means that if you switch the places, right, and you inject it into the map afterwards, right, then you're actually going to override it. And this is freaking insane. It is actually hanging. It's ridiculous, which means that I made some other typo somewhere. Let's try with partial real quick. Let's go over here and do partial. It also hangs. What's up with you? Let's try with the real ZIO. Oh, it is the real ZIO. Whoa, let's go to hours. Hours is fine. I guess we can go and use the real one over here, right? So if you have it like, if the order is like this, then it's not going to use it. But if the order is like this, it's actually going to use it. All right, so I also want to make provide some layer work, which is this one. And as of right now, it needs a little bit of help, right? So if we do provide some layer and then do partial and do fancy console.live, it is going to require a little bit of help. And we need the ability to provide only one type over here, right? To help out with only one type. We need to be able to do this. So we're going to go and we're going to do the same trick as we did with the access functions. Okay, so we're going to go to provide some layer. Okay, I wanted to provide some layer like this one. Okay, so I'm going to copy it. So it's going to look exactly like this. It's just that it's not going to have the R0 over here. It's going to be apply, right? And it's going to be like one further over here. There's going to be a class, right? So it's going to be a final class. We're going to call it provide some layer. It's going to have this R0 that we used to have over there, R0. Okay, like this. Okay, so it's just going to have this apply function. And so now over here, we are going to have only the R0, right? Like only this part. We're not going to have any of that stuff, right? We're just going to have that. So this whole thing is not going to produce a ZIO. It's going to produce a provide some layer of R0. And the implementation is going to be, new. We don't need to specify new. We're just going to do provide some layer of R0. Like this. Okay, so this is going to be provide some layer, and we're going to do the same trick for provide custom layer. And remember, I told you in the beginning that we're also going to improve the provide layer. We're going to make it a little bit more strict over here. We're going to put the R0 over here as well. Okay, so now we're going to do this, and now it's going to be green, and it's going to be fine. Okay, so now we're going to do the same trick with the provide custom layer as well. Now let's go and try to use provide custom layer, which is the last one. Like this, okay, and it needs to have the same trick. It needs to have a little bit of help. It needs to have okay, so where is it? So provide custom layer, it calls provide some layer. It needs to have the ZIO environment over here, like this. And yeah, there we go. This is already enough. And by the way, we should probably also do the same thing with the provide layer, like this division into a class, because like every time you have like all of these parameters and they're unnecessary, like every time you're going to run into issues with type inference, you want the ability to just provide the R1. Okay, so I'm going to do the same trick. We're just going to copy that, paste it over here, call it apply. Like this, just remove the R1 from here, and then it one further to the right, we're going to have a final class. We're going to call this one provide layer. It's going to have some R1 colon like this. Okay, so now over here, it's going to be provide layer. All of this is removed. All of that stuff is removed. Like this, and it simply returns a provide layer of R1, and it simply constructs a provide layer of R1 like this. All right, there you go, the same thing. All right, so now the most important point, right? We're going to go back to M1, right? So we're going to go to M1, right, main one. And we're hiding the fact that the business logic, for example, uses Google. So if you wanted to inject a fake one, and I'm going to simply paste it, right? So we have the fake console, and over here, I'm going to paste in the fake business logic somewhere over here. Notice that over here, we're just simply succeeding with a false, right? The real business logic calls Google, right? So the real business logic, calls, Google account pictures, blah, blah, blah. Over here, we're simply returning false, right? And so now I would need to reconstruct the environment that does not even have Google, right? So I would grab this guy, go down. Okay, like imagine that I was in my tests, right? So we would create a fake environment over here, right? Over here, right? So I'm going to say that this is the fake env. Okay, so it does not require Google, right? It does not require Google because over here it's going to use the fake business logic that does not require Google. Okay, like this. This is the fake environment. Should totally be fine. It's probably not fine again. Like was this any over here, right? So it's probably going to be happy with the has of any. Okay, cool. So I'm just going to simply leave it out. Okay, in the real ZIO it would be fine. Okay, so now it looks like this. Okay, so this is the fake environment that does not even require Google, and so now I can go and I can even do like provide layer, right? And I'm gonna say fake environment, right? fake environment. Okay, and now both of them are going to return false, right? There's kind of like no magic there. Like you would do this was like with any programming language, was any like you're not going to have the DSL, but you're going to have like a regular for comprehension or whatever. You're just going to leave it out. It's all good. Now if we go back to the second one, and I was really worried about this when I was learning ZIO. I was really concerned that the fact that Google is required is not hidden from the declaration side over here. Right? So I was really concerned that when I'm going to fake my business logic, I'm also going to be forced to fake Google, which again, it is possible because this is, Google is abstract, right? But it's super unnecessary. So I was super worried about this. But it turns out that my worries were for nothing because I don't even need to reconstruct the dependency graph, right? I can use the real dependency graph, which uses the real business logic, which uses the real Google. And then in the end, I can just say plus fake business logic, right? And so like all of this production stuff is going to be ignored, all right? So let me go to the bottom and paste this again, like the same thing as we did over there in the main one, right? So we're going to inject it over here, right? So we have the fake business logic over here. And in this case, we're going to return true so that I can, if I make a mistake and I switch to main one instead of main two, we're going to see it over here, right? So look, it still says that it's going to use Google, but it actually doesn't use it. Okay, so I was really concerned about this, right? So that it's not hidden, so I'm kind of like forced to use Google, but I'm not. And so now in main one, we're constructing this fake environment. In main two, we don't need to do this. I can simply provide layer over here with the real dependency environment, right? The real one, right? And I can just simply go and say fake business logic.live, and now both of them are going to return true. And it doesn't, because the presentation gods are not on my side today. I was actually about to tell you that if I injected before, that it's not going to work. Like this, right? Then it wouldn't work. Oh, actually, hold on. I think I know what. Yeah, because of this. Yeah. So we're injecting it before, it doesn't work. But if you inject it afterwards, it's going to work, right? So we're going to do ++, and then it works, right? So now both of them return true, right? So when you're faking stuff, it's even easier, even though the information is not hidden. The real layers, by the way, also have a method called, update. You can like update some layer instead of like doing this ++ thing, sort of like manually. Now, everything in life has a trade-off. For example, over here, it's very easy to accidentally forget to override part of the dependency graph, and then all of a sudden on your CI, you're sending real emails to real customers. Also, for some reason, if you go to, if we go back to main one, there are parts of this thing that are going to compile, but they're not going to do anything. For example, if we go and let's, for example, go over here and we're going to do dependency graph.env ++ fake business logic.live, right? It's going to compile, but it's not going to do anything, right? Because like over here, it wouldn't know like even where to inject this thing, right? So it's simply going to ignore this. It doesn't matter if you use it on the left or on the right. It's going to compile, but it's actually not going to do anything, right? We're in main one, right? So don't get confused with the main two, right? But this is like, these are like some things that, like nothing is perfect, nothing is bulletproof. There's still like some weird limitations that you need to be aware of. So again, when I was learning ZIO, I was very skeptical about this part, and I still am a little bit for things like the errors, right? So with the errors, we have the same problem, right? We have it is hard coded over here in the trait that the implementation is not allowed to throw any exceptional, to produce any errors. With a traditional text final approach, the interpreter, which is the implementation of this trait, was the one who was that was in charge of saying like, hey, I'm actually going to produce some errors and you have to deal with them somehow, right? Over here, you're a little bit more, I guess, constrained, right? So in your trait, you have to specify it, but at least you have covariance, right? So for example, if you have like your ADT was like 3 errors, and in your implementation, you could say that I'm actually going to produce like only one of them, right? So you have like a little bit of flexibility, but it's a little bit more rigid than what you would have in Tegless Final, right? Like because you're hiding like a little bit less. In fact, you're going to see that once we're going to start rewriting the Tegless Final to-do app, we're not going to actually go with this idiomatic ZIO approach, right? We're not going to have layers. We're going to have like extra type parameters. Like for example, when I started working on this thing, if you look at Google over here, right, I actually had a version that I'm going to copy paste. I'm going to insert it like somewhere over here, right? I started with something like this because I was really concerned about hiding this fact, right? So I was like, in my type alias, I would have like the R and the E. So I would have the has of Google service of some R and E, just so that I don't have to hard code the fact that something is used over there, right? And then I ended up with like these weird signatures. And I believe in the very end, it didn't even compile, because once I reached the controller, the type signature was like freaking 2 pages long, and I just gave up. I also ran into issues with has, because has the invariant type. Like ideally, there should be a minus over here and a plus over here, but I can't do this because has is invariant. But again, like in the rewrite of the tegless final to-do app into ZIO, we're actually going to use this approach, because we're not going to use layers. So we're not going to use has, we're not going to use we're not going to use the reader monad at all. So we're actually going to end up with something like this. For now, let me actually throw this out. So I already have like a very cleaned up version of this uploaded for you on GitHub. The link is going to be down in the description. In fact, the link was down in the description since the beginning of the series, right? So over here, like ZIO nutshell, and I split everything up into files, right? So you have a file for console, you have a file for has, you have a file for ZIO environment for the runtime, very, very, very tiny one, right? And you have the main one and you have the main two, right? The main one is the regular stuff where you hide information, and the main two is where you track the effects, right? It's all cleaned up, and it all works just fine. All right, so let me go back over here. All right, so we're finally done with the first portion of the series. And the second portion, we're going to rewrite the tegless final to-do app into ZIO. But as already mentioned, it's not going to be idiomatic. It's going to be very, very pragmatic, right? I imagine that like in real life, you would actually have an application tegless file, and you would want to rewrite it into ZIO. And this is how you would do it. After this, you can rewrite it like even more properly and introduce the layers and stuff, okay? But before we move on to the next video, allow me to point out a couple of things. ZIO is gigantic. I could not possibly cover every little thing of it, but allow me to mention like just a few things. The first thing is that the regular ZIO also counts with aliases for the common types for the common slots in your ZIO. For example, a type like this one that we use all over the place, right? So like it's all over the place. Like, so for example, over here we have like, okay, over here we have only 2 of them, right? It's a ZIO, because we're in the main 2, okay? But over here, if we have like ZIO any, right? So like any nothing, like for example, this part, Alt F3, look, we have like, we use this type in 10 places. The real ZIO comes with aliases. For example, this particular one is going to be called UIO, right? It's the one that doesn't need anything, doesn't need the reader monad, and it never fails. You also see exactly the same information on the very first page of the documentation of ZIO, and I avoided it because I find them a little bit confusing. And only once you get very comfortable with ZIO, you should start using them. And also, they have companion objects, right? So there is also a companion object called UIO, and for example, it doesn't have the method defined on it called fail, because a UIO can never fail. Me personally, I'm not going to use at least the companion object because I want to minimize my diffs, but you do whatever you want to do. The second reminder is that the real ZIO environment does not only have the console, it actually has, and, clock.clock, and, blocking.blocking, and there's also a random generator, and there's also a thing that can read the environment variables for you, and so on and so on. Thirdly, the real ZIO has literally hundreds of helper methods that allow you to do any crazy things, like even like mono transformer like things. For example, it's very common to have some like a function like find, right? And it's going to return an option of A in the success channel. But ZIO also provides you helpers that allow you to move this option into the error channel, for example, right? And it allows you to do the same thing with an either, and you can go back and forth. It's very, very convenient, very, very composable. I'm simply mentioning this over here because the to-do app that we're going to rewrite, it barely has any error handling at all. The last point is the one that I already mentioned, but I'm going to repeat it. Like technically ZIO is a concurrency library, but in this entire series, we're barely going to touch upon concurrency because I really think that the whole reader part is way more important, way more complicated, way more unfamiliar. This is why I spent like so many videos talking about this. And once you understand that, like everything else is going to be trivial. For example, ZIO has many types to start with the letter Z. We have already seen like Z environment. We have already seen like Z layers. There are many others like Z streams and so on. And I couldn't possibly cover all of them. Just RTFM and you're going to be fine as long as you understand the reader part. Like this is the most complicated part about the whole ZIO thing. And one more word about concurrency. People usually get really, really excited about fibers, especially with Project Loom, when it's going to come. But even the documentation of ZIO advises you not to use fibers directly. Use the abstractions that are built on top of fibers, like zip-parv, for example. And by the way, the same thing could be said for actors. Like actors are a relatively complicated abstraction. They are great if you're building tools on top of them, like if you build your own database, for example, right? However, like using actors directly in your business applications is not going to be good. The same thing can be said for fibers, right? So for example, Akka has streams. They're built on top of actors, but you don't see that, right? So Akka streams are awesome, right? But you don't see the complexity that comes with the actors. And the same thing over here. You rarely should use fibers directly. You're really gonna need to use fibers directly unless you're doing some really, really complicated things. All right, I hope that you enjoyed the series so far, and I hope that I'm gonna see you in the next one. For now, as always, it's been Vlad from devinside.com. Don't forget to like this video if you did, subscribe if you want to improve the developer inside you, and if you learned something today, consider supporting me on GitHub sponsors or Patreon, whatever you prefer, and let's watch my videos weeks and sometimes even months before everyone else. Like this series is probably already over. And most importantly, take care.